Welcome to The Explainer. Today, we're tackling a big one, a concept that sits right at the heart of quantum mechanics and is, frankly, pretty weird. We're talking about superposition.
All right, let's kick things off with a puzzle that seems, well, impossible. But here's the cool part. You can actually see this happen with your own eyes, just using a few simple polarized light filters. Okay, so this isn't some kind of CGI trick. It's a real experiment, and honestly, it completely messes with our everyday intuition. So let's break down how this impossible puzzle actually works, step by step.
Okay, so first up, we take two polarizing filters. Think of them like tiny little fences. The first one only lets light waves waggling horizontally to get through. Then we put a second filter behind it, but this one's fence is vertical. So what happens? Exactly what you'd think. Nothing gets through. Makes perfect sense, right?
Okay, but this is where it gets weird. We take the same setup, the horizontal and vertical filters, but now we slide a third filter in between them, an extra obstacle set at a 45-degree angle. And boom, suddenly some of the light makes it all the way through. How? How does adding another barrier let more light pass? It just doesn't make any sense.
I know, it feels like a magic trick, right? But it's not. This is a real-world peek into one of the strangest and most powerful ideas in all of science. It's a fundamental rule of how reality itself works.
So to get our heads around that crazy light puzzle, we have to dive into this idea called the both-at-once principle. The fancy name for it? Quantum superposition. Okay, so what is superposition? Here's the key takeaway. Instead of a particle being in one state or another, it's actually in all of its possible states at the exact same time. It's not a choice, it's everything at once. And this slide, wow, it just nails the difference between the computers we use every day and the quantum world. A regular computer bit, the kind in your phone, is like a coin that's already landed. It's either heads or tails, a 0 or a 1. Simple. But a quantum bit, a qubit, that's like a spinning coin. It's a blur of possibility that is, in a very real physical sense, both heads and tails at the same time.
So let's bring this back to our light puzzle. The light coming through that first filter, it wasn't just horizontal. It was in a superposition of all possible angles at once. That middle diagonal filter we added, it didn't just block stuff. It interacted with the light. It kind of measured it at that diagonal angle. And by doing that, it forced the light that got through into a brand new superposition. And this new state, well, it now had parts that could line up with that final vertical filter. That's why some of it got through.
But, and this is a huge but, there's a catch to all of this. This whole both-at-once state, it's incredibly fragile.
Yeah, check out this quote from physicist Anton Zeilinger. He basically says that superposition only works as long as there is absolutely no way to know, not even in theory, which state the system is in. The second that information gets out, even a tiny bit, the whole thing just vanishes.
That's the bottom line. The very act of looking, of measuring, it forces a choice. The magic just disappears. The system has to pick a side, a single, definite state.
This whole process has a name, wave function collapse. And you've probably heard of it from the famous Schrodinger's cat thought experiment, right? The cat inside the box is in a superposition of being both alive and dead until you open the box. The act of looking, of measuring, forces reality to pick one outcome.
Okay, but this isn't just some mind-bending theory to argue about. This quantum weirdness, it's actually the engine driving a whole new generation of absolutely incredible technology.
Seriously, we're learning how to actually use this stuff. We're talking about quantum computing, creating totally unhackable communication, even building super-sensitive sensors. And get this, it even explains secrets in nature, like how plants are so ridiculously efficient at photosynthesis. Turns out, they use superposition too.
And this really drives home just how powerful quantum computing is. Your laptop is like a musician playing one note at a time, right? Sequential. But a quantum computer, using superposition, can explore all the possibilities at the same time. It's like playing a massive, complex musical chord all at once. The power jump is just exponential. And this isn't just for subatomic particles anymore. Look at that number. That's 10 trillion. That's how many atoms were in a tiny little tuning fork that scientists managed to put into a superposition of vibrating and not vibrating. At the same time, a macroscopic object.
But you know what? The story doesn't even end there. Scientists are still pushing the boundaries, debating what observation and collapse really mean for the nature of reality itself. Yeah, some really cutting-edge research with large-scale magnetic fields is giving us totally new ways to think about how our solid, predictable reality actually takes shape from this fuzzy quantum world.
This research is suggesting there might be two different kinds of collapse. First, there's informational collapse. Think of it like a sensor just choosing its own version of reality from all the ones that are coexisting. But then there's energetic collapse, where real physical interaction happens and it actually forges a brand new reality altogether. It's wild stuff.
So what's the big takeaway from all this? Superposition shows us that reality, at its deepest level, isn't some single fixed thing like a photograph. It's more like a cloud of pure potential, a symphony of possibilities just waiting for an observation, an interaction, to snap it into a definite form. And that leaves us with a final, really mind-bending thought to chew on long after this is over. If the act of looking actually changes reality, what is reality like when we're not looking?